All right, I want to take a look at this midterm exam here. I'm not going to do all the problems all the way through. I'm probably not going to do any of the problems all the way through. Um, but I want to talk about mistakes that people made and things to avoid and give you some things to think about as you're redoing these for the extra credit. Okay, so you take the limit as x goes to 3. First thing you might try anytime you're taking a limit is just plug the thing in. If you've got a nice function, continuous function that the limit's equal to the function value. So, try it. This is 9 plus 6 minus 15 over 9 minus 9, which would be 0 over 0. Okay, well, that didn't work, right? 0 over 0, though, tells us that there is more work to do, that there might be a thing here. So we factor, right? That we factor top and bottom and cancel out the 0 over 0. One of the things, though, is because these are polynomials, you know that x minus 3 has got to be a factor of both of them. Seem to have something on the table underneath there. So x minus 3 has got to be a factor of both of them. Oh, now what's the other one? This is an x plus 3. This is, what this must be, an x plus 5 or something like that. You can then, you're still taking the limit as x goes to 3, but at this point the x minus 3's cancel out. Plug it in, see what you get. One thing is that sometimes I see people do some incorrect algebra and just right from the start they say, oh, look at that, cancel out the x squareds. Right? If you're doing things like that, I might have written algebra. Means you just made an algebra mistake, not a calculus mistake, an algebra mistake. Something you're doing is not legal. So you got to tell me about it. You got to say, hey, I canceled out these x squareds, but the reason I can't do it is because, look, these are added together and not multiplied together. And, try it with some numbers. Try the, plug x equals 1 in with it this way, cancel them out, and then try to plug in x equals 1 in and say, hey, look, you got different answers. So somehow that's not right. Anyway. There's that one. This one, again, if you plug the 4 in, number 2 here, if you plug the 4 in, you got a square root of 4 minus 2 over 4 minus 4, which is 0 over 0 again. So, we got to do something else. And in this case, there's a couple ways people have done this. Some people factor at the bottom. Some people just multiply top. They multiply by 1 in the form of radical x plus 2, radical x plus 2. And then the thing is the numerator is going to turn into an x. That's a 2 radical x, that's a minus 2 radical x, they cancel out, and then you've got the minus 4, and that x minus 4 is going to cancel with the other x minus 4. So generally people did pretty well with that one anyway. This was a limit as x goes to infinity. So what's happening there is it's the biggest powers of x that dominate. I mean, when x is big, say x is 1,000,000, so this would be a minus 2,000,000 there, which you might think is pretty big, but 1,000,000 squared is a trillion, so you got 5 trillion minus 2,000,000. It's like, the 5 trillion dominates. So really, those aren't important, and you're left with the 5x squared over 4x squared, which really looks like 5 over 4, and in the limit, indeed, the answer is 5 over 4. Oops, I wasn't supposed to do the problem all the way through. But again, I see people, well, actually, in this one, there were other things that people did, which, most people did this fine. I was going to say they factored out the x's, but when you factor out the x, they cancel. It doesn't make any difference. Yeah. That one, I guess, people did pretty well with. What do we have? 4 minutes. So next page, definitions. What's the definition of the limit? I told you I was going to ask you this question. The definition of the limit is very precise. It has epsilons in it and it has deltas in it, right? This has epsilon and delta in it. In it. Go find the definition, right? We talked about it. We used it. Just learn that definition. That's just one of the things I want you to do. Likewise, continuous. A function is continuous at x equals a if what? If the limit as x goes to a of f of x equals f of a, right? That I saw people get close to this, that somehow they say, like, they leave off the limit as x goes to a, or they, I don't know, there's variations, but it's a continuous function at x equals a if the limit as x goes to a of f of x is the same thing as what happens when you get there. It's f of a. Right? What's the definition of the derivative? This is one that was, of the three, this one was probably gotten correct most often. The book actually gives two definitions for derivative, one for derivative at a point and one for the derivative just anywhere. I accepted either one of those, but right, it's a limit as h goes to 0. So given a function f of x, f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. If you've got those definitions wrong, you got to explain to me where, what you were doing. Were you just giving sort of this is the general feel of what the definition is telling me, but the strict definition is this. I don't know. Show me that you've learned those definitions. Anyway, number 7, intermediate value theorem. Show that this function has an x-intercept somewhere between 0 and minus 1. The intermediate value theorem says if you have a continuous function, so first of all, I note that f of x is a polynomial, which we know is, so it's continuous everywhere. Continuous everywhere, here we go. If it's continuous everywhere, it's continuous on the interval from 0 to 1. And I know that f of 0 equals 0 cubed minus 3 times 0 plus 1, which is 1. I know that f of 1 is 1 cubed minus 3 times 1 plus 1, which is minus 1. So the function value at 0 is 1. The function value at 1 is minus 1. It's a continuous function. It's got to get from here to there. So the intermediate value theorem says it has to pass through every y value between f of a and f of b. Notice that 0 is in between minus 1 and 1. So there's got to be a spot somewhere in the middle that crosses through 0. So, whoops. There exists c, so that f of c equals 0. We could also make the argument that there's got to be somewhere where the function is equal to a half or minus a half or anything in between minus 1 and plus 1, because we got a continuous function. You had to say it was continuous. Show me the endpoints, one of them higher than the value you want, one of them lower than the value you want. So there's got to be a spot that hits the value that I want. Okay. 8 minutes. I'm going to keep going here. Next. Use the definition of derivative to find the slope at the point x equals 3. So the thing is, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. In particular, I'm only interested in x equals 3, so I think in this case it might be easier to actually plug the 3 in before we do anything. The limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. So wherever I see an x, right, I'm plugging in the 3 for x here and there. This just has fewer variables involved. It makes the calculation a little bit easier. Right? Yes, we can take the derivative of this thing knowing some shortcut rules from later on in the course, but this was use the definition of derivative. So here we go. F of 3 plus h would be, sorry, I'm still taking a limit as h goes to 0. So this is the square root of 2 times 3 plus h, right? Wherever the x is, I'm plugging a 3 plus h in for it. Minus f of 3, so that's the square root of 2 times 3 all over h. So I've got the limit as h goes to 0 of the square root of 6 plus 2h minus 6 all over h, right? And then continue from there. I'm not going to finish this one. I'm going to let you actually calculate that limit. You know, some problems that I saw here where people they would write this as the square root of 6, and then the plus h was on the outside. It's like they plugged the 3 in for x, but the h stayed on the outside. If you're doing things like that, then you're going to have to explain to me the difference between f of x plus h, f of x plus h, and it's not equal to f of x plus h, and show me how you know the difference. What is this versus that, and how is that that what you did was this when what you should have been doing was that, right? Explain to me those things. If you're getting that h on the outside when the h should be on the inside, then you're mixing up the function notation here. Okay. Likewise down here, number 9, use the definition to find the derivative of this function. Again, I know that many of you just said, hey, I know that's x to the minus 1, so the derivative would be minus 1x to the minus 2. It's like, but I asked you to use the definition. So I want you to take f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. So as you plug that in, this function is saying whatever input you give me, I'm doing 1 over that thing. So if I give you an input of x plus h, I should have a 1 over x plus h minus f of x is 1 over h. If you've got this as 1 over x and then a plus h on the outside, then just like I said in the last one, you're mixing up this kind of stuff. You're figuring out what f of x is and then adding h later, rather than making x plus h the input and using that as the input. So explain to me how that works. Show me examples of other functions and plugging stuff in like that. Show me that you understand that notation. This is all over h. This is a big fraction now. You're going to have to maybe get a common denominator or multiply top and bottom by that common denominator. There's different ways that people proceed. But this is probably the biggest problem people had on this one, is not getting this right here. Okay. Anyway, keep going from there. All right, I think I'm going to stop this video at this point, and we'll do the rest of it in the next video.